Hello and welcome to a new session on the topic ArchiMate for Architecture Modeling in alignment with the TOGAF Architecture Development Method ADM. In today's discussion, we start the technology domain, the infrastructure, the system architecture. This is all synonym to the technology domain. If you take a look at the PDF we downloaded from the ArchiMate library from the Open Group, we are now in chapter 9, technology domain. Let's get started. So this is the status quo we have. We ended up with the application layer showing our microservices with an application gateway, front end and customer, even third-party interaction. Let's take a look at the bigger picture we had in the business architecture. These were the processes we have from upload products, browse catalog, add to cart, checkout, process payments, even up to the processing of the order itself with the third party in the warehouse and the delivery partner and the different interactions between them. Another view that we had also is here, where we had the recommendation system format. And moreover, we had the return process modeled here, which is of interest to us because it shows the central hub, the warehouse as well, and the different interactions between them. So we start with adding a new ArchiMate view, technology domain. We try to lay out the infrastructure that would support all of our system as much as we could, and now we are in the green layer. You can see it is separated into two domains, the technology domain and the physical domain. The technology domain, it's more about the nodes, the devices, and the network. The physical domain is more about the facilities, the material, and the equipment, and the paths, routes connecting them, or distribution network. Here you can see we have here a communication network. Here is a more of physical network. Both of them are physical, of course, but you get that this is a network as we know it in the terms of technology, and this could be a path or a roadway. However, this can fit into your architecture modeling process. You know, this is to be interpreted in the physical layer of the architecture. So we'll start first with a node. Here we have a node. How many nodes should we have? So we'll have our cloud nodes. Are we in the cloud or in the data center? This is also something that should be modeled. Or would we have a hybrid system of both of them? We stick to our case study of having an online retail or online store. So we will assume in all of these modeling sessions that we are in the cloud. Of course, assumption is to be validated with the stakeholders, etc. And it is not uncommon to have a hybrid system between the data center and the cloud, or entirely data center based system. So here we have a node, and the node is technically a computing machine of different specs, could be high enough to support our microservices. And how many nodes do we have? We will have 3 nodes for high availability, redundancy, and consistency, so that if we have the situation where one node goes down, the other one will pick up. Since they are all to be modeled in the same way, I will write down here node 1 to n. So this applies to all from 1 to n. You can also choose to have the cardinality model with having an extra node connected to it behind the load balancer or the firewall. It could also be of interest to have a node with the compute intensive machines, and you have a node with storage oriented machines. So this could also be the case. So this we can also model here this node for compute intensive compute node. Let's duplicate it, and each one with its own redundancy specs and storage nodes. And if you are in an AI system, of course, you will need a GPU oriented node where you have all of your GPUs attached to it, and then you can make sure that the applications in the classic sense of application does not really consume any GPU cycles or cause overhead on your GPU that is needed for the AI models. So we have here our nodes and how the nodes are communicating with each other, of course, over a network. Interesting here is you have a path and a communication network. Let's see both of them, a path and a communication network. One of them is a realization of the other. I would assume the communication network is a realization of the path. It realizes, yes. So you realize, implement this path, this connector between the node, compute node, and the storage node using a communication network. It could be a VPN network. It could be, if you are in the cloud in Microsoft Azure, it could be Azure Backbone Network. This also ensures that if you are modeling a cloud architecture, perhaps this is a good point where you think about virtual net pairing, or having a virtual endpoint, virtual network endpoint for your services, so that the communication flows over the Azure backbone. However, this can apply also to the AWS cloud architectures. So you are well covered here when we talk about this kind of technology or infrastructure domain modeling. And then this is connected in both directions, and the flow is both ways actually. So we map the flow in this direction and also in that direction, and implicitly you understand it's also the data flows from the storage node back to the compute node using this connector, but the trigger is from the compute. The compute says fetch this data from the storage delivers it to the compute. So quite a start. We have pretty much a skeleton where we can fill it now with our system specific annotations. So pretty much familiar now with all of these components. You can see we have again the node, the device, this is a system software and a collaboration. So this is perhaps let's have a look at this one. So you can say this is SAP system software. So this is a system software. This is the annotation used, double circles overlaying each other. So this is one way to model it. Or it could be Linux, Windows. This is also one of the possibilities. Then you have a collaboration of two active structures, of two behavior structures, and then you have interface, again technology interface is different. This could be some of the hardware protocols. For example, you can have MQTT, or you could have different hardware protocols that need to be modeled, so you can have them using the hardware technology layer interface. The path we have seen, the communication network we have seen, function, technology, function, technology, process. You can have a collaboration, interaction, a collaboration and interaction. These are two different elements. We have said in previous session that we have behavior elements and we have structure elements. If you combine behavior elements, let's have a look here. These two behavior elements, these are technology services. The combination of these two services is an interaction. Let's verify that. Service triggers flows to associated, and let's verify the collaboration. Service trigger flows to associated and realization. So this a collaboration, realization. Quite confusing to get that always right. So this was also the same here, collaboration in the business layer and interaction. Collaboration and interaction in the application layer. And the same for this one. So a collaboration realized by two services. And an interaction, let's choose a structure element. In this case, what could be the structure element in the application layer? Two devices, or device and a node. These don't perform behavior, so these should be structure elements. And see realize. Let's see the node realize. So the technology interaction is realized by the structure elements, device and node. Technology collaboration is realized by the behavior elements, service, component, process, function. We are here. Let's add these ones for the sake of explaining this. Again, let's double check one thing here. So pretty much correct what we have so far. So just for guidance on collaboration and interaction, we haven't covered them extensively in previous domains in application and business domain, but the same rule applies in each of the previous domains as well. So we have two nodes. A node, we said this is a compute machine, a computer, a server machine, and they are connected with a bus which is realized by a communication network. This communication network is Azure Backbone, VPN, VNet pairing. So many ways to realize this one. Taking a look at the system, we have the storage. How we are going to model that one. So an ArchiMate artifact element. So an artifact here, this could be a package, jar file. It could be a files on the system. So these are the elements that we can encounter. You can also add more examples if you find. And the rest is here is the technology event. So this could be some physical event on the hardware layer. It could be an interrupt if you are working in embedded systems. ecosystem, and the technology service. So we start with adding a system software. We have find out here that the compute node runs a Linux, could be an enterprise version, could be just Linux Ubuntu, could be Linux, another variant that's more suitable for this use case, but this is the foundation of this Linux. So now we are pretty much modeling correct, very explicitly the implementations. And then when you communicate this with DevOps teams, or you communicate this with other stakeholders, or in the implementation team and the developers, they can pretty much relate to this. So you say you have a node with the Linux Ubuntu, so you can imagine what are of the skills needed to build up the team for this project. If you are using a continuous architecture that says that you build your architecture first, draft first, and then you build your team based on that, not the other way around. Have the team sitting idle and then see what architecture can you build with this team. And this is the Conway rule that says the architecture reflects the team structure. And this way you say if you give two systems to two teams, one team of three sub teams and other of two sub teams, you end up with 3 microservices and other with 2 microservices, because it reflects the team organization. But in continuous architecture, you do it the other way around. Of course, you start with the architecture and then build up the teams needed to implement the architecture. So pretty much here, Linux Ubuntu, you need some Linux administration skills in the background so that you can manage this cloud or infrastructure. On the storage node, you have a database management system. Could be MongoDB, could be Oracle. You could be very specific and say which variant you are using here. I will say just database, DBMS, database management system. This would be the backbone. And what else is needed on the storage node to make it so it has redundancy because nodes 1 to n. What you need is a device. So you need to empower this node with RAID storage, redundant storage. How we model that one is using devices here. So this is a device, we say SSD 1 to n. And one of the things to note here, it could be RAID storage, could be software defined storage, be SAN storage attachment network. But you can see here, you are very clear that this again is a composition or an aggregation. If the storage can exist on its own without the nodes, is it shared storage between the nodes? But I would be explicit here and say each node has its own storage, and then the DBMS makes sure there is a redundancy and replication, sharding, partitioning, etc. I'll say it is composition relation. I could also do that by having the SSD attached to the storage node directly on top of it. For sake of convenience, I'll show it attached from outside so it's explicit. For this kind of nodes, I am putting the value on the storage. So I need here high disk IO, or I need to focus on the aspects that make the database function properly. So I show here that we have high IO, or even more specific, I/O is related to the disk itself. You can be specific and say 3000 IOPS, input-out operations per second. You can even go further, and instead of having storage nodes redundant and replicated only, you could also have hot standby replica, hot and cold replica, or hot replica, or hot standby replica. However you choose the pattern, this is also possible. So we could go a little bit further and model the node for the replication. It is a node standby replica node 1 to n. Here's one of the things interesting. Are we going to have for every node a standby replica, or are we going to have one standby replica of our own? How fast can the replica kick in? These are all questions to be answered. And the network connection flows to the replica, but only when the standard primary nodes are down. And we can give us a little bit more space and fit in page. So our diagram now is taking shape. And on the replica node, we have the same specs as much as possible. So for redundancy, I will not repeat it here. Let's look at the compute nodes. So on the compute nodes, we have a Linux, Ubuntu. Good point to start thinking, are we going to have the Kubernetes or another orchestrator, Kubernetes node or Kubernetes engine? Just say Kubernetes. One of the things that are not to forget is the firewalls. These are very essential for the security. So we need to model a firewall layer here. One of the system software. And let's not forget the firewall also is to be attached in front of the entire system as a central global firewall. How we are going to do that is the firewall is a device, is a node. I will stick with being a device, firewall. So any communication that's going through to our cluster, that will be over a firewall. You can even go specific with grouping so that you can show the clustering of the system. So showing the flow, anything that's coming from the outside world is going through the firewall. So we have a Kubernetes cluster with Linux, Ubuntu, and firewall. And on Kubernetes, we have our own services, bots. We can have cron jobs. We can deploy the services. And we can add ingress and egress. So we'll start now with adding services. So we have assigned to this node, the Kubernetes system is egress, ingress and egress. and E. So it makes sure that all communication passes through this. Can readable ingress. Ingress. One of the things we could do is to highlight the Kubernetes cluster with all its components, making sure here it stays at the top. So this is our own cluster, and the ingress and egress are parts of it. So this is the parts for the communication. And then we have the application pods, application services. We have cron jobs. We have what else we could have in? We have roles and permission RPAC, Kubernetes security components. Pretty much quite complete. One of the things we can do is ask a question why we have a Kubernetes cluster only for the compute and not for the storage. And this is quite a debate if the database should also be hosted on Kubernetes. There are schools or opinions that say the storage is independent from Kubernetes for different reasons that make the storage more performant from design for the virtual machines, etc. And there is a discussion that says now the Kubernetes operators, they make it possible to have the storage on the Kubernetes cluster. We have here, for the sake of variation, one with Kubernetes, one without, so you can see how versatile, how diverse, how powerful the ArchiMate annotations could be. I would say this pretty much covers the application layer. So perhaps we could now make it smaller. Along the way, in an incremental process, you can always add different more components and augment incrementally this architecture. And you can see that so far it's quite agnostic. It could be deployed in cloud, it could be deployed on premise. We have not done anything that's on cloud only or on premise only. One of the things that could also be utilized here in relationship to the physical layer, or we could also use the location from here. So this is a location. You can add here a facility from the physical layer. You could say now this entire node is in Delaware data center. for reasons, logistically reasons. So now you have a physical aspect to your architecture as well. So this is the Delaware data center, very clearly where you're having these compute machines. For logistics reasons, it could be cheaper to have the compute machines there, it could be more efficient, it could be where your team is located, support team. The reasons could be numerous. And we could do the same. Let's have this a little bit more aligned. We have missed one of the firewall has been lost in the background. Here it is. Moving element is not quite as easy. Pretty much it. So this is Delaware's center, and we can choose another one that's not located there. That is located physically different, and say this one is located using a location annotation this time, because we should be consistent. And this is a different location. It could be in Seattle. And this implies there are more data centers there. Perhaps we have the storage from Oracle or another third-party provider, and then that's the reason why it's only a location, Seattle location, and not specifically a data center with a factory. So this, at least I will ask, is there a reason why you are modeling the Seattle as a location and the Delaware only as a one data center? And say the stakeholder would say, yes, there is only one data center in Delaware out of this and that historical reasons. Looks pretty much solid now. And here we are, we have completed one possible architecture proposal for the technology domain, the infrastructure, the cloud architecture, data center architecture, on-premise architecture, infrastructure. These could be named many ways, even system architecture. So this integrates well with our ADM from TOGAF, in which we start with motivation, strategy, business architecture, application architecture, and technology architecture. So you can see now how this fits well with the ADM process using the ArchiMate notations, which is quite versatile, that supports many ways to do and model the architectures and different meanings and interpretations of each notation. You could add many further annotations that completes your architecture in many different ways, and incrementally iterate over this architecture to complete it, but you get the idea what is possible using the ArchiMate. And to emphasize, I'm not advocating that ArchiMate is the only way to model architecture, but it's one of the comprehensive, structured ways and systematically built and aligned with the TOGAF method. And it helps you as someone who is trying to take the certification exam of TOGAF or ArchiMate. I hope these sessions have helped you to get some hands-on tangible experience how it could be applied in practice using these hypothetical scenarios and case studies. Thank you for watching. See you in future sessions.